Welcome to all. In this video, we are going to see about fault model in VLSI circuit. Before going to the topic, what are the faults present in logic circuits? That is stuck-at fault, temporary fault, bridging fault, transient fault. In this lecture, we are mainly focused stuck-at fault model. Okay, before that, what do you mean by stuck-at fault model? That is, the most common model used for logical faults is the single stuck-at fault. Single stuck-at fault. It assumes that fault in a logic gate results in one of its inputs or output is fixed at either a logic 0 or logic 1. That is stuck at 0 or stuck at 1. It is named as a stuck at fault. That is stuck at 0 and stuck at 1 faults are often abbreviated to stuck at 0, stuck at 1. So, what do you mean by stuck at fault? That means any one of the outputs is any one of the output is fixed at either 0, logic 0 or 1. That is named as a stuck at fault. Let us discuss with one example circuit about stuck at fault. So already we discussed what do you mean by stuck at 0, what do you mean by stuck at 1 fault. That means any one of the input or output fixed either 0 or 1. If that value is fixed, this input line is fixed as 0 means that is named as a stuck at 0. Suppose this output line is fixed as 1 means that time that fault is named as stuck at 1. Whatever input you are given here, but this line is considered only 0. That means here affected by stuck at 0. Affected by stuck at 0 means at the time this value input line is always considered 0. If you are apply one value in this x1 value is 1 means at the time also it is considered only 0 because this line is affected by stuck at 0 fault. Okay. Consider this circuit. This circuit has 2 AND gate, 1 inverter, 1 OR gates. Okay, totally it has 3 inputs, one x1, x2, that names are x1, x2, x3 and only one output, that is y, that is named as y. So this is a primary input, this one is named as a primary output. So from this circuit, first you have to calculate what are the fault sites present in this, how many number of fault sites present in this circuit. That means this line is considered as one site, fault site. This point is considered as B point, that is named as B. This point is considered as one fault site. Then this line also considered as another fault site. Okay, Y means this point, from this point we take one point to another gate. So here we consider 2 fault site present in this line. Okay, like we are calculate how many number of fault sites present in this circuit. That means A, B, C, then this point is named as C, D, then this point is named as E, F, G, H, I. Totally it has 9 sites, fault sites possible to occur. From this one we are calculate how many number of faults occur in this circuit. That means say either stuck at 0, this point is affected by either stuck at 0 or stuck at 1. Now we are calculated how many number of fault sites present in this circuit, that is 9. From this one we are calculate how many number of single faults present in this circuit. That means 2 represent either stuck at 0 or 1. Totally it has 2 for stuck at fault model. So here we multiply with 2 value in our total number of fault sites, that is equal to 18. So 18 faults present in the circuit. So if suppose the circuit is affected by stuck-at fault. The circuit is affected by stuck-at faults. So from this example circuit, we calculated how many fault sites present in this circuit. In this circuit, total number of fault sites are 9. So from this one, we calculate single faults of the circuit. That is 2 into 9, 18. So this is one kind of calculation of faults in our circuit. What are the possible faults occur in our circuit? How many number of faults followed in this circuit? Okay. Next, we are going to consider this G line is affected by stuck at 0. This G line is affected by stuck at 0. So now from this circuit fault, we can find test vector. We are going to find test vector. Which test vector going to identify this kind of this fault present in our circuit? So that is only let us discuss step by step. Okay. So now you consider this G line is affected by stuck at 0. Okay. So this is our given statement. From this one, we are going to find test vector. So which type of test vector we are going to apply, then how can we able to find that fault present in our circuit? Okay, so let us discuss one by one. Consider G line is affected by stuck at 0. Before going to find the test vector, first we have to make one truth table. Okay, so already we know that is totally the circuit has 3 inputs, 1 output means, so 2 power 3, 8. So this circuit has 8 combination of inputs. From this combination of inputs only, we are going to find this kind of fault. Okay, so first we are going to we are going to make truth table of this circuit. Okay, that is fault free circuit, fault free output circuit, faulty output circuit. We are that is consider 3 inputs, that is x1, x2, x3. In this table we put like this. Then next column we are going to write fault free response value. Then after that near this column, next we can write faulty response value. Okay, so in this one, so already we discussed 2 power 3 equal to 8 combination of input, that is write like this 0 0 0 0 0 1 0 1 0 and like up to 1 1 1. We are writing like this. We are making the truth table like this. From this one we are write response of this circuit when we apply input combination 0 0 0. Okay, at the time this is AND gate, consider this is AND gate. So when we apply value 0 0 for this input line, means at the time what is the output here? 0. Then next this 0 goes to the inverter circuit. What is the inverter logic? While input of inverter 0 means at the time output of this line point is 1. So now 1 and 0 is the combination of input of this AND gate. So what is the AND gate logic? 1 into 0, 0. So here also 0, here also 0. What is the output of this value of OR gate for this combination of inputs? 0 plus 0. OR gate means plus logical OR operation. Okay, logical OR operation. 0 0 means what is the output? 0. See, like we are make truth table of this circuit, that is fault free response circuit. Then Now what is our objective? How can we detect the stuck at 0 fault present in this circuit? So what is the procedure means? Next, consider this line is affected by stuck at 0. So whatever output value present in here, that always this line is considered only 0. Okay, always this line is considered 0. When will we get 1 in this gate? At the time of combination of 1 1. That means we are apply 1 1 means for this AND gate. Apply 1 1 means at the time. What is the output of this AND gate? 1. What is the output of this gate? AND. But this line is affected by stuck at 0. So whatever value present in this line, but this fault consider only 0. Okay, because this line is affected by stuck at 0. Okay, wow. Then now this original response value equal to 1, but this line is affected by stuck at 0. So this line value is invariably 0. So based on this fault value, it will give faulty response in this point. Okay, so similarly we are apply all the combination of inputs to this circuit, then we can write a output faulty output of stuck at 0 at G line. Okay, so in this one now we compare while we apply 0 0 0 at the time, what is the fault free response? 0. Also faulty response also 0. So we are not able to find the fault when we apply this kind of test input vector. Okay, when we are able to find the fault vector means similarly we compare both values, that is fault free response and faulty response. Like we are make truth table. Finally look at this table, final combination of input, that is 1 1 0 then 1 1 1. This is the fault free response value, this is the faulty response. So for input combination of 1 1 1, what is the fault free response value? 1. What is the fault free response value? 0. Now this value is differ from fault free response. So this is the one of the test vector to find the fault present in G line. Similarly we are compare the another response value, that is while we apply input combinations are 1 1 1. At the time, what is the original response value? 1. What is the faulty response value? 0. That means the G line is affected by stuck at 0. So from this table we are able to find what are the test vector going to apply to find the G line is affected by stuck at 0. So what is the value of this fault means, that is 1 1 1 0 1 1 1. So while we apply this combination of inputs, then only we are able to find fault in this G line. We are able to find faults present in this G line. So hope everyone understood this concept, what is mean by stuck at fault model. So what are the concept? This named as two way. There is stuck at 0, stuck at 1. Already we know the stuck at 0 and stuck at 1. Suppose this line is affected by stuck at 0 means that line is considered only 0 value, whatever may be given input. Okay, so that is stuck at 0, then this value consider, that value always consider 1. Okay, so from this example we are find how many number of fault sites present in our circuit, then how many number of faults present in our circuit if that is affected by stuck-at fault. Okay, that is only single faults. So from this one, we consider one example. The G line is affected by stuck-at 0 means what is the test vector for this line is affected by stuck-at 0. What is the test vector? So this is the test vector, that is 1 1 0 1 1 1. This is the test vector to find the faults at G line. Okay, hope, thank you all. If you have any doubt, we can clarify in the next session.